integral. The central block is used to connect the two forks. First, the fork is assembled with the central block with the holes in alignment. The shaft and the key is now assembled to the hub. Then a cylindrical pin driven through the aligned holes and fastened at the bottom using a collar and a taper pin. In the same manner, the other fork is assembled to the other half of the central block. After assembly, the forks are oriented 90 degrees to each other. This coupling allows the angle between the axes to vary while the shafts are running up to an extent of about 25 degrees. Now you are viewing a completely assembled universal coupling. This animation presents to you the application of universal coupling in the propeller shaft of the automobile. Here the universal coupling functions as a constant velocity joint.
So that is regarding universal joint or universal coupling. Now after seeing this animation, we will discuss how to draw the detailed drawing and assembly drawing of this universal coupling. So this is the drawing of one end, that is fork end of this universal coupling. The first component, that is fork end, through which the shaft is inserted in this keyway. This is the diameter of the shaft, and this is the keyway of 8 by 3.5, and through this keyway the shaft is inserted over here. So that is first component, fork end. This is the front view of fork end, and this is the top view of fork end of universal coupling. Now second component, this is the second component, which is called as the center, and through this component two pins are there which are at right angle. Here one vertical hole is there, and here this is the hole in which a pin is inserted, and here this is the horizontal hole through which another pin is inserted. So these two pins which are inserted over here allows to have the axial movement in any direction up to 25 degree angle, and this is the detailed drawing of center of this universal joint. Now third component, that is shaft. The shaft is drawn over here. The length of shaft may be any depending upon the requirement, and here number 4 is the parallel key or rectangular key is here, having width 8 mm and thickness 7 mm. So these two drawing shows the detailed drawing of shaft and parallel key, and here section line is represented to show that it is a circular cross section. Other components, that is pin, two pins are there having diameter 16 mm, and 25 millimeter at the head, that is a pin named as number 5. Number 6 is the collar having thickness 10 millimeter, diameter 25 millimeter, and here small hole is drilled or small hole is provided to insert a taper pin for proper assembly of collar and taper pin having diameter 16 millimeter. Number 7 is a taper pin. This is a taper pin and its specification is 4/30 and taper 1:30. So every after 30 unit dimension, its taperness reduces by 1 millimeter. So total length is 30 millimeter. So here the difference in dimension at one end and another end would be 1 millimeter. So that is the taper pin. Now this shows the exploded view of universal coupling and assembly of universal coupling. If we assemble the universal coupling, these are the elements: pin, one end, another end, fork end and eye end, and if we assemble together, this would be the assembly drawing of all these components. First we have seen the detailed drawing of each component, and now this represent the assembly drawing of universal coupling, showing the cross sectional lines where the material will be cut, and it shows the sectional views of the taper sanki, flange and both the shafts as well. And this is the bill of material or part list for this universal coupling, which includes first fork, 2 quantities made up of cast iron material. Second is the center made up of cast iron material, quantity 1. Third is the shaft, 2 shafts are there of mild steel. Parallel key, 2 keys are there of material mild steel. 2 pins are there, material mild steel. Collar, 2 collars are there, material is also mild steel. And number 7 is taper pin. 2 taper pins are needed because 2 pins are there and 2 collars are there, and which is made up of mild steel. So this is the bill of material or part list for assembly of the universal coupling. Now next is the assembly of simple eccentric. So before drawing the assembly and detail of simple assembly, eccentric, let me see its working principle through this animation video.
Simple eccentric. Simple eccentric is used in steam engines. The D-slide valve is reciprocated by the simple eccentric assembly. The main parts of this assembly are the sheave, the straps, connecting bolts and nuts, and shims. The sheave contains the eccentric bars to carry the crankshaft end. The 2 straps are used to enclose the sheave. One of the straps has provision for connecting with the D-slide valve. The sheave is assembled with the straps so that the projection in the outer periphery of the sheave is located in the recess of the straps. Shims are provided in between the straps in order to adjust for wear in the sheave. The straps are fastened together by using cheese-headed bolt, nut and block nut.
So that is regarding eccentric, which is used in the steam engine. Now we will see how to draw assembly drawing and detailed drawing of plumber block. So before that, let me see how it is assembled and how it is drawn and how it is made up of which components. Plumber block with the help of solid edge. So first we call each component one by one in the solid edge. First is a body or main body of an object. This is the main body of an object which is put over here. It is called. After that, bearing bottom, the bottom portion of bearing, and assembled together or met the surfaces that we select the fit, this bottom surface, and first we assemble these two components, selecting this surface, and it needs to be matched with this circular hole, face hole, so it is assembled. So these two components are assembled now. Okay, move the parts. These parts it could be moved like this because we need another component that we select this one. This surface, it should be co-inline with this surface, so make both these surfaces coplanar, and this surface should meet this one, so both are met together. Now the assembly is constraint free. All the constraints are satisfied in this assembly. Now bearing top portion or top bearing is to be inserted to the top side, considering all the constraints and all the surfaces which needs to be met should be selected. For example, this axial movement should be restricted. So to restrict this axial movement, first let we coplane this surface and this surface. So both these have become coplanar to each other. Now our objective is to make both these surfaces coplanar. So both these surfaces have made coplanar with the command. Now we call one more component, that is shaft. This shaft is called. Select this shaft and insert this circular shaft in this circular hole. So select both the surfaces, this one. So this shaft is now coaxial with this axis of this circular hole, and to insert this shaft inside this assembly, let me coplanar its surfaces as shown over here. So now this shaft is also assembled together in this assembly. So these planes represent the axis of shaft as well as the hole. Now we call the bolts. Two bolts are there which are inserted in both the sides. One is over here, another bolt which is to be inserted over here. So selected this portion, bolts are inserted and active assembly is made. And now after inserting these two bolts, our task is to restrict them to move in particular direction. So for that, let we call coaxial, let we make it this surface coplanar with this surface, this one, so that both become the coplanar like this or parallel to each other to have proper assembly of these components. Now let we select this surface so that the head of this bolt coplanar to both the bolts as well as this surface. So this is made coplanar with this surface. Select both this face and it is assembled now. So this is made now. Now one more component, nut. Both the nuts are to be inserted in the top side after assembling this surface. So here we can put this top cover like this, so that these nuts, these bolts are to be assembled with this cover. So now this cover is assembled in this assembly with these two nuts, two bolts, and these two bolts should be inserted through these two parallel holes which are drilled in this top cover. In the plane of this top cover, this plane and this plane, both should be parallel to each other. Hence we select this surface as well as this inner surface, mate them. So now this assembly is completed. Only nuts are needed to be added in this assembly. So let me select the nuts from this part list, lock nuts. So select this nut, click over here in the part list of plumber block that we call nut. Now it is 2 nuts are there, so both the nuts are called over here. This surface, this face coincides with this, so it is inserted over here. Similarly, the constraints are made. This axis, this surface of the nut and this surface of plumber block should mate each other. So with the help of constraints we have assembled this nut. Similarly, this face should mate with this upper face, so this is assembled here. Similarly to the first component. Now here also again we will select the bottom surface of this nut, this one, as well as upper surface of this top face, and assemble them together. So this makes assembly of the plumber block. Now lock nut needed to be added over here. Select this lock nut, select over here, and it is inserted in this one. Similarly, this lock nut should also be added in the another side as well, with the same steps to be followed which we followed in the first assembly. Select this bottom surface, click over here, so it is assembled. Now make the constraints clear. Select another lock nut, pick it up from its storage, assemble this, select this surface face which meets the edge of this nut, select this face, select this outer face, assemble it. So this is the assembly of lock nut in another side as well. Now we clear all the constraints, move this along this, and select this bottom surface of the lock nut and upper surface of this hexagonal nut and make an assembly.